Good morning, everyone. We're going to start the presentations here. Thank you all for coming today. My name is Travis Sentiment. I am the director of Friends of the Big Sioux River. We are excited to host this event for the third time. And we're here to bring awareness and to celebrate the river that flows through our backyard. And my hope for each of you is to take away something new and develop a deeper understanding of the Big Sioux River. See if the technology will work. And guess what? It doesn't. There it goes. Okay. So, Friends of Big Sioux River, we're a nonprofit organization dedicated to water advocacy. Our mission is to protect and restore the Big Sioux River and its watershed. And we focus on four main areas: water quality monitoring, advocacy, river restoration, and education. These core areas all aim to improve our local community and foster a stronger conservation ethic. For today, so we're going to kick off with a presentation of the state of our river and our 2024 water quality testing data presented by our education and outreach manager, Emily. Following Emily's update on water quality trends, we're going to hear from Tim Stepanich of Advanced Engineering and Environmental Services on his presentation Forever Chemicals 101, What are PFAS? This talk will provide an overview of PFAS, their history and operational challenges associated with detecting and removing them. Following that, we're going to hear from Sammy Blood and her presentation on PFAS in the Sioux Falls region. This presentation will focus on municipal and private well contamination at Joe Foss Field, where firefighting foam containing PFAS was used from 1970s to 2018 by the Air National Guard. We're going to discuss the new EPA regulations around PFAS water and the state's plan for testing and removal. And then finally, we're going to have some updates from Jay Gilbertson with East Dakota Water Development District regarding some PFAS testing they are starting to do on the Big Sioux River. And then I'm going to talk about I did a blood sample of my own blood to see how much PFAS I have within my system, and I'm going to kind of show you an update on what that looks like and talk about how we all have amounts of PFAS in our system. And then after that, we'll have a short Q&A. I would like to extend a special thank you to Augustana University and their Office of Sustainability and Environmental Studies program for helping to sponsor this event. And I would also want to recognize the great partners that are here today. You probably saw their booths out in the lobby. ISG, the City of Sioux Falls, Minnehaha Conservation District, and Binfluencers. Please take time, if you haven't already, to talk to them after presentations are over and to see all the great work they are doing. But before we get Emily up, we'd love to show you the new mission video we just put together. And then from there, we'll get into the meat of it. So thank you again for coming today, and hopefully you enjoy yourselves.
Loving a place is not enough. We need a willingness to protect it. The Big Sioux River is worth protecting. It connects us to each other, to nature, and to generations to come. The river is a place where our community truly comes together. For generations, we've gathered along its banks, sharing moments of joy and connection. Whether we're casting lines into the water, floating on kayaks, cycling along its paths, or simply exploring together, the river has been the backdrop to countless shared experiences. But it's not just about us. The river supports a diverse array of life, sustaining everything from the fish that glide through its waters to the birds and other wildlife that find shelter along its banks. Our close connection with the river can remind us of what truly matters, the life, beauty, and cycles of the natural world that sustain us all. If we want to pass along a world worth inheriting to our future generations, we must be diligent stewards of our environment today. Protecting the Big Sioux ensures they'll be able to appreciate the same wildlife, recreation, and connections that have enriched our lives. Our actions today are the legacies we leave for those who come after us. Rachel Carson wrote, "In every outthrust headland, in every curving beach, in every grain of sand, there is a story of the earth." The Big Sioux River contains that story for our community. We only have one river and one future. Join us in our efforts to protect it.
Wonderful. Well, welcome everyone. As Travis mentioned, my name is Emily Oyas, and I am the Education and Outreach Manager here at Friends of the Big Sioux River. Today, I'm going to be talking a little bit about our 2024 water quality testing data. But first of all, I want to go into what is the Big Sioux River watershed, how large is it, where does it flow through. So our river, the Big Sioux River watershed, is about 9,000 square miles. Most of it is here in South Dakota, but a portion of it does extend into Minnesota and Iowa as well. The river itself is 419 miles long, starting just near Summit, South Dakota, north of Watertown, and it flows on down, obviously, through Brookings, Sioux Falls, Canton, and then it empties into the Missouri River down at Sioux City. Everyone who lives within this watershed is impacting the water quality of the Big Sioux, as well as all the streams and tributaries that you see on this map. So we all live downstream of someone else, and we're all impacting the water quality of our local watershed. So just some water testing basics. What do we test for at Friends of the Big Sioux River? We're testing for 3 contaminants: E. coli, total suspended solids, and nitrates. E. coli is going to be a bacterium that we find in the intestines of animals as well as humans, and it's safe when it's within our bodies. However, when we go to the bathroom, or when a cow or a pig, for example, goes to the bathroom, that E. coli comes out in their fecal matter, and if that happens to get into our local water sources and we drink that water, if you're going swimming in the Big Sioux and you accidentally get a mouthful of water, you can get pretty sick from E. coli. So that's a big one that we're testing for. Total suspended solids are going to be things that you can physically see floating in the water column, such as sand, silt, soil, algae, that sort of debris. And then we have nitrates, which are an essential source of nitrogen in the nitrogen cycle. However, they're often found in excess in our waters due to fertilizer runoff and pet waste, etc. So where do we collect water samples at? We have 18 different sites that we're testing throughout the summer months from May through September. We test from Dell Rapids down to Akron, Iowa, and we're testing at sites including the Big Sioux River, Split Rock Creek, Skunk Creek, 9 Mile Creek, along with some local wetlands and lakes. We are using the South Dakota Volunteer Water Quality Monitoring Program guidelines, which is set forth by the South Dakota Department of Ag and Natural Resources, which I'll be referring to as DANR today. So we're following the state's standards. After we collect our samples, they are put directly on ice, and we take them to the airport same day, and they get flown to Pierre and tested at the state health lab there. Why are we collecting water samples? We are sampling our local lakes, rivers, and streams to help determine the water quality of the Big Sioux River watershed as a whole. And our sampling results are included in DANR's Water Quality Monitoring Access Portal. They're also used as part of the integrated report, which I'll get into a little bit later on. And they're posted to our website to allow public access to our data. So we want people to know what the water quality is of Big Sioux. We want people, especially if they're going swimming at like Lake Lakota or Lake Elvin or Wall Lake, we want them to be able to see the water testing data there, so they can determine whether it's safe to go swimming or not. So here are the kind of basic results and implications that we have as a result of our 2024 water testing data. Number one, in 2024, we received a lot of rain. We know that we had our flooding events earlier on in the summer, and this year Sioux Falls received about 19.42 inches of rain between May and September. Last year, on the other hand, we only received about 9 inches of rain. So with that 10 inches of rain difference, we saw worse water quality levels because we had increased runoff and as a result, a reduction of water quality. So right now what we're seeing is when we have increased rainfall, that's leading to higher rates of runoff and erosion and thus reduced water quality. So in years with lower than average rainfall, like 2023, our water quality levels actually looked okay. But this year, especially E. coli, wasn't looking so great. Going into that, our rivers and streams are regularly exceeding their safe levels for E. coli. This year in particular, we had 3 sites that recorded levels of 24,200 colony-forming units per 100 milliliters, which is the maximum E. coli test that the state public health laboratory can test for. So when we get those results back, it just says greater than 24,200. So we don't know if that number was 24,500 or if it was 30,000, 40,000, etc. But our safe level for E. coli is 235. So for immersion recreation. So obviously if we have a safe level of 235 and we're at over 24,000, that's not good. So to help reduce that E. coli, obviously getting cattle out of the river, as well as picking up after your pets, putting more riparian buffer strips in to help reduce that runoff and erosion and everything that's happening. And then finally, nitrate levels. Nitrate levels continue to gradually rise year over year in the Big Sioux River. On average, nitrate levels continue to remain within their safe standards of 10 milligrams per liter. However, this year we did have one site within Palisades State Park, a campground stream that flows right through the campground there, that every single test we did was over that safe level of 10 milligrams per liter. So high nitrate levels are definitely something to keep an eye on. Our city tests for them in our drinking water to make sure they're meeting the standards, but if our nitrate levels get too high, that can lead to things such as blue baby syndrome, cancer in adults, thyroid issues. So especially if you have well water and you're not having water that's treated by the city, you definitely want to test your well water for nitrates, because there could be some lingering nitrates in your water that could be causing health issues for you. And one way we can fix that is by picking up after our pet waste and also reducing the amount of fertilizer application, both on our lawns as well as in agricultural areas. So here's that hard data for you to look at. As I mentioned previously, we have 18 different sites that we test for that are labeled on the left-hand side of the screen there. We also have our 3 contaminants listed, our total suspended solids in green, E. coli up in orange, and nitrates in yellow. Within each of these columns, we have the total number of samples that we collected this year, the average of those total number of samples, the lowest number of those samples, and the highest number. Anything in red is going to be over the safe level. And so our safe level for E. coli is immersion recreation or swimming. Nitrates are going to be for drinking water, and TSS is going to be up there as well. So with our red numbers, TSS this year actually looked really good. All of them on average were meeting the standards of 235 milligrams per liter. So we were really happy to see that, and a little bit surprised with the amount of rainfall that we had and the erosion that occurred in runoff, but TSS looked pretty good. E. coli was another story. You can see that about half of our sites on average were at or exceeding that safe level, and almost all the sites except for one, which was Wall Lake, had at least one exceedance of that safe level. So we were having a pretty big E. coli problem. We have those couple 24,200s up there. We've got some at 19,000, 15,000. So definitely not a great year for E. coli at the sites that we tested. And then finally, we have our nitrate levels. As I mentioned, all of our sites except for the one at Palisades Park were within that safe level of 10 milligrams per liter. Here we have a 7-year overview of water quality. So at Friends of the Big Sioux River, we've been testing for 7 years now, and we have 6 sites that have stayed the same over those 7 years. So they are listed up here in the different colors. The red dotted line is going to be the total rainfall at those sites from April through September. And so what we're seeing, we have our TSS, E. coli, and nitrates broken out in each graph. And basically what we're seeing, as I mentioned before, is that when we have higher rainfall years, our contaminant levels are shooting up. And when we have lower rainfall years and we're more in a drought, our contaminant levels are lower. So increased rainfall is leading to increased erosion and runoff, and thus increased water quality levels. Obviously, someday we'd love for us to be able to say we have the correct conservation practices in place, and so even though we're getting an appropriate amount of rainfall, our water quality levels are still staying within that safe level. However, that's not the case right now. I do want to point out in the E. coli column, the purple line is Lake Elvin. We were only able to get 6 samples at Lake Elvin this summer because they drained it in about August to repair the spillway that was damaged in the 2019 flood. So since we had that flooding earlier on in the summer, we had higher E. coli numbers there. And so they weren't able to average out later on in the August and September. So just want to note that is why there's that crazy spike with Lake Elvin right there. So just a few more things before we get into our keynote presentations for today. Now we're going to kind of look at the Big Sioux River as a whole, not just looking at Friends of Big Sioux River's testing data, but at some state testing data. So every 2 years, South Dakota Department of Ag and Natural Resources puts together what's called the Integrated Report for Water Quality Assessment. This is a statewide assessment of all of our lakes and streams, and it's required by the EPA to put this together, and it's also put out there for the citizens of South Dakota. Within the integrated report, there are what are known as designated beneficial use standards. And so the EPA is specifying, and they're requiring all states to specify goals and expectations for how each water body is used. Here in South Dakota, Danner has designated all surface waters in the state for 11 total beneficial uses, for one or more of those. Examples are going to be things such as domestic water supply, so things like drinking water, immersion recreation, which is going to be swimming, where you might physically get your head wet and go underneath the water. Limited contact recreation, so things like fishing and kayaking, and then finally fish life propagation. Those are just some of the examples. When a water body is impaired and not meeting those standards, then it is considered non-supporting. And in that case, then the state must put together what's called a TMDL, or a total maximum daily load. And they're basically saying this is the total amount of pollution that a water body can receive and still support its beneficial uses. And so this TMDL must be developed for impaired waters, and the state is also required to specify quantifiable targets and actions that they're going to take to get it back to its designated beneficial use. So the state is basically telling the EPA, this body of water, or this section of a body of water is impaired, and here are the actions that we're going to take to get it back to a safe level. So the integrated report itself is a huge report, and we've tried to go through it a little bit to make it a little bit easier for folks to see what's happening. The integrated report itself uses a pass-fail system to determine water body support. So if a water body exceeds those parameters by 10%, it's considered non-supporting or failing for its beneficial use. A water body that does not exceed 10% is considered supporting or passing. Due to the nature of this pass-fail system, it's hard to easily determine water quality if it's improving year over year. For example, a segment of the Big Sioux River may have exceeded its beneficial use standard for, let's say, limited contact recreation in 2014 by 60%, but this year it's only exceeding by 15%. Either way, under both circumstances, it's still considered failing or non-supporting because it's not at that 10% yet. So that's kind of one shortcoming of the integrated report right now, is that it doesn't show that percentage of exceedances, so it's hard to accurately represent changes in water quality between reporting periods. So we created these graphs to illustrate that change in non-support and support for, there are 3 contaminants from 2004 to 2024 based on that pass-fail system, which is contained in the integrated report. So until there's more readily available data regarding year-over-year change in percentages, we'll just continue to create these graphs based on that pass-fail system. So these 2 graphs are showing the Big Sioux River as a whole. The Big Sioux is split into 16 segments from the headwaters near Summit down to Sioux City, Iowa. Our first graph here has our total suspended solids, our E. coli, and our nitrates. E. coli wasn't tested for specifically until 2010, so that's why that orange line starts a little bit later on. E. coli itself spiked in 2018. It's been going down, trending downward since then. However, we did have one segment that had E. coli in it this year that was non-supporting, so that's why we saw that small spike. Nitrates had a small spike early on in the 2000s, and then ever since then, it has been full support or 100% supporting. So that's really great to see. TSS, similarly to E. coli, has spiked and now is leveling off. So these are telling us that water quality is slowly improving over time. In regards to E. coli, we've broken it down even further on the right-hand side. So the dark blue line is going to be immersion recreation, which has stricter standards. Obviously, you want to have pretty strict standards for the water bodies that you're swimming in with immersion recreation. So for that example, the Big Sioux is at 100% non-supporting for immersion recreation in the segments that are designated for immersion recreation. So none of the segments that are designated, and there are 9 of those, none of those are meeting the immersion recreation standard. So obviously, we'd love to see that number come down, but that's not the case right now. Limited contact recreation, on the other hand, that kayaking and fishing, that number has started to trend downwards. So that number isn't nearly as strict of a safe level because you're not getting your head wet and there's less possibility of accidentally ingesting the water that way. And so that's telling us that E. coli is improving slowly year over year because that limited contact is starting to go down, and we'd love to see that immersion recreation going down as well. So what are our key takeaways from our data today? 1, water quality is directly impacted by rainfall because when rainfall washes sediment into the river from rural and urban areas, then we're getting decreased water quality. While the current trend line is hopeful, we must keep diligent on goals and protection and remember that we all live downstream of someone else. And there are actions that we can all take to improve water quality, whether that be picking up your pet waste, reducing fertilizer usage, installing buffer strips, putting a rain garden in. Everyone from urban to rural folks can make a difference. And as a collective community, we can all start to improve our water quality. So it is now my pleasure to introduce our first speaker. Tim Stefanich is a Senior Advanced Technical Specialist with Advanced Engineering and Environmental Services in the Sioux Falls office and has been with the company for 3 years. He previously worked for the City of Sioux Falls Water Division with 30 years experience dealing with drinking water regulatory compliance issues. Tim is a graduate of South Dakota State University with a Bachelor of Science degree in Civil Engineering and a Master of Science degree in Environmental Engineering. Tim, welcome.
Thank you. Appreciate it. Thank you, Emily. Appreciate that introduction, and I appreciate the opportunity to come and talk to you guys about PFAS. I've been talking to water operators, wastewater operators across the state for about the last 5 to 10 years about PFAS, just because I've been dealing with it when I worked with the City of Sioux Falls for about the last 12 years or so before I left. And so I've garnered quite a bit of information about PFAS, and so it's, I've been trying to provide that information to anybody and everybody that I can, and I really appreciate being able to come and talk to the general public about this. And so what we're going to do is we're just going to talk a little bit about forever chemicals. So we're going to do what are PFAS. We are going to cover just a little bit of chemistry. I think it's important that we cover that under PFAS because I think it helps you to understand what actually PFAS are and how they affect the environment. And so I don't want to cover it too much because I don't want to glaze everybody's eyes over and roll back in their head. So we'll just cover it just a little bit. All right. We will talk about some health effects and drinking water regulations, and then we'll talk a little bit about treatment options. So what are PFAS chemicals? PFAS stands for per and polyfluoroalkyl substances. And so if you see there's 2 separate words there. There's a perfluoroalkyl substance and there's a polyfluoroalkyl substance. They are all covered under PFAS. And what we'll do is in a couple of slides here, we'll actually define what per and polyfluoroalkyl substances are. They are a group of over 10,000 fluorinated organic chemicals. The last I've seen, there are upwards of about 14,000 that they're actually detected right now. And there's all sorts of different chemical structures that they deal with. And a lot of it depends upon what the definition of PFAS actually is. And as of right now, even EPA doesn't quite understand They haven't figured out what they want to use as their definition for PFAS. We classify this as an emerging contaminant, mainly because it's brand new for water systems, wastewater systems, and the environment. We're doing a lot of research trying to figure out where this stuff is, how it moves, how we're going to treat this stuff, and how are we going to take it out of our environment. So, it's all just starting right now, and we're learning a lot of information as time goes on. And unfortunately, this stuff has actually become ingrained in almost everything that we use. PFAS is everywhere. Literally, it is everywhere. And it's in a lot of the products that we actually use. And we'll kind of go through that here in just a little bit. So what makes up that PFAS? It's that carbon-fluorine bond. This is not a natural bond that occurs in nature. They actually need a chemical or a industrial process to actually create that bond. So if we find PFAS out in the environment, we put it there. It's not something that is natural, let's say like a heavy metal, like a lead or a chromium or arsenic or something like that you can find naturally in the environment. PFAS, you do not find naturally in the environment, so we actually put it there. It was actually discovered by Dr. Roy Plunkett, who was a chemist who worked for DuPont back in the early 1940s. And like with any good chemist, he actually found it by he was doing other experiments, so it was by accident that he actually determined it. So he was working with CFCs or chlorofluorocarbons. So he was looking at refrigerants, and so during his experiments, he was expecting a gas out of this experiment, and he actually got a white particulate that attached to the inside of his vessels. And so they started doing research to actually figure out what this stuff was, and it was Teflon. And so Teflon was born. It took it about 6 years, 8 years to bring it to the consumers. They had those the nice Teflon coated pans that they introduced back then. And it was a panacea for people because all of a sudden they had non-stick pans and pots, and so it was perfect. The only problem is that it started to become everywhere in the environment. So right now we're finding this stuff in soil, air, water, and as Travis talked about, even in our blood, and we're finding it in humans, fish, animals. They're actually saying up to 98% of humans in the United States have PFAS in their blood. There are different levels. It all depends upon how you are exposed, but you do have PFAS in your blood, and I'm really interested to see what the levels that Travis has in his blood. The two most well-known PFAS are PFOS and PFOA. PFOS is perfluorooctane sulfonic acid. PFOA is perfluorooctanoic acid. And they're two different types of PFAS, and at the time they actually had a very good usage. Non-stick, things like that. As I said, these are man-made chemicals. They are not found in nature. And so what did manufacturers see with these things? What was why were they so enamored with PFAS? Well, basically it's that oil, water, stain resistance. Anything that you have that is oil resistant, water resistant, stain resistant is probably made with PFAS. That's the coating that's got on it. So if you have textiles, you have shirts, jackets, all of your outdoor gear that is water resistant, if it's stain resistant, it's probably coated in PFAS. That's what gives it that quality. Little kids' clothes are all coated with PFAS just for the stain resistance. They are also heat resistant, and they make things chemical resistant. So why wouldn't a manufacturer just love these compounds? Because it's a one single PFAS compound that can do all of this stuff. And so it was just like they had died and gone to heaven. I mean, this stuff was just beautiful. The only problem is that all of a sudden we find out that they're water soluble. They have a low volatility. They are resistant to biodegradation. So in essence, microorganisms can't break them down. So it's a bond that basically is very, very hard to break. So we're finding that's why we're finding it all over, in the environment, is because nothing breaks it down. So in essence, it's basically called the forever chemical, and that's why you may hear certain reports on TV, research, things like that. People will start calling this the forever chemical. It's because this stuff doesn't break down naturally. We actually have to take it out of the ground, out of the soil, and then give it a high heat or something like that to actually break that bond between the carbon and the fluorine. So where are PFAS used? This is just a snippet of some of the industries that actually use it. And so as you go through those different industries, think of the things that you have used that may have been manufactured by each of these. They probably all have PFAS in them. And so that's why we tend to see that they are everywhere in the environment. Here are just some individual products that are actually manufactured that utilize PFAS. And anything from, and I got to get closer here, pesticides, stain-resistant products, firefighting foams, microwave popcorn bags, let's see, eye makeup, pizza boxes, paint solvents, varnishes, cleaning products, nail polish, dental floss, non-stick cookware, water-resistant clothing, shampoo, candy wrappers, and fast food packaging and wrappers have all been known to contain PFAS. There are a few of those things on this list right now that have been removed, especially the food packaging. The FDA has banned the use of PFAS in food packaging, so now that is all gone. One of the things that was interesting is I've been watching the pizza boxes that come into my house, especially the pizza that is very greasy. The PFAS would actually be coated on the inside of the pizza box and doesn't allow that grease to actually penetrate into that cardboard, so that when you put it on the table, you don't leave a grease spot on there or on your couch or something like that. Well, now all of a sudden that PFAS is going to be gone. There's not going to be any addition, there's not going to be that coating on the inside of that box to prevent that grease from seeping through that cardboard. So it's just one of those things to notice as you turn over the pizza boxes, is that grease is probably going to start to soak through that cardboard. They're hoping to find other chemicals that they can use, but I think EPA is going to be a little bit more trying to do additional testing to make sure that the chemicals that they are going to apply inside of those pizza boxes are not going to be like PFAS. They're not, you don't want health effects associated with them and everything else, because what they were finding is that the actual food products were absorbing the PFAS from the packaging. And there are all sorts of studies out there that show that that has actually occurred over time. And so it's just one of those things, for body burden that can happen as you absorb that PFAS. One word on firefighting foams, because as Sammy comes up here and she's going to start talking about PFAS around the Sioux Falls area, this is one thing that we have been dealing with, is firefighting foams. There are two types of fires, basically. Class A, Class B are the major ones. Class A is a timber fire, brush, basically wood products. There are foams that they can use to extinguish Class A fires. Those do not have PFAS in them. It is the Class B fires, those that are for fuels, solvents, things like that. Those will have the PFAS in them. So those are typically at Department of Defense sites, airports. The FAA actually required not long ago for airports to carry foam that had PFAS in it. So they call it AFFF, or aqueous film forming foam. And it was notorious for being used at airports and having contamination at those sites. The FAA and the Department of Defense are getting away from AFFF with PFAS in them. They've actually do not manufacture them anymore. They're still there's still some out in storage, but the FAA is not requiring airports to use AFFF with PFAS in them anymore, and so they're slowly doing the switch over to non-fluorinated firefighting foams. Here's the chemistry discussion. So the molecules actually, let's go back and let's go, okay, the difference between perfluoroalkyl and polyfluoroalkyl. So perfluoroalkyl is where the molecule is, or the compound is actually fully fluorinated. So in essence, what that means is that for every carbon that's in that molecule, there is going to be fluorine atoms that are attached to it. So every single carbon has a fluorine atom attached to it. So it is fully fluorinated. This one is 8 carbon chain length. The chain length can actually vary anything from, we've seen down to 2 carbons in the chain length all the way up to about 14. So it just all kind of depends upon the manufacturing process and what they're looking to use the compounds for, but they tend to be fully fluorinated, is the polyfluoroalkyl substance. And then they have the poly is the non, or there are some sites that may not necessarily have fluorine attached to them. So here's the carbon here, and actually got a couple of hydrogens. You can also have other chemical structures that are attached to that carbon, and so these molecules can actually get very, very large. And so those are considered the polyfluoroalkyl substances. Perfluoroalkyl substances cannot break down. That's as far as they go down, unless you put like a high heat or something like that to it to break those bonds. Polyfluoroalkyl substances can actually break down further, where those bonds are between the carbons that maybe have the hydrogens or the different molecules attached to there. They can break there, but what they're going to break down to is a perfluoroalkyl alkyl substance, and therefore it's not going to break down any further. And so that's one of the issues, is that with the polyfluoroalkyl substances, is that they will break down to perfluoro, and then they're just going to float around in the environment, and we're not going to be able to get rid of them. And so there's that chain length that we talked about, and there's a reason for that, is that there are long chain and short chain. So when you have a perfluoroalkyl substance, you can have a long chain, which tends to be 6 or 7 more carbon atoms in length. These tend to be the legacy PFAS compounds, or the older ones. They don't make these anymore. Basically, EPA said, we're finding these things in humans. It was especially with the people that worked in the manufacturing facilities. They were finding that the PFAS was accumulating in these people, and so what EPA said is, now we can't do that anymore. So we got to get rid of this stuff. So they do not make long chain PFAS anymore. At least in the United States. I know some is still made in China, but basically the United States cannot import any products that have long chain PFAS compounds in them. They tend to be more bioaccumulative, so in essence they absorb into your body for a lot longer. Long chain PFAS can be in your body upwards of 8 to 10 years or longer. And so it takes a long time for your body to desorb those long chain PFAS compounds. One nice thing is that they are easier to treat, and so they absorb better onto like granular activated carbon or something like that. So at least there's maybe something good that comes out of it. There is the other side, which is the short chain stuff. When EPA said you cannot manufacture long chain anymore, manufacturers were going, okay, so now what do we do? And somebody came up, why don't we just cut the chain? Okay, so what they did is they just made a short chain, which is now less than 6 or 7. They found that these were not as bioaccumulative, so they don't stick in your body as long, as to where the long chain were in your body for years. Short chain may only be in your body for maybe days to weeks to months. And so you tend to rid yourself of those short chain a lot faster. Because of that, the regulations may not be as strict, and then also, unfortunately, they're more difficult to treat on the shorter chain side. And again, these are the newer PFAS compounds, because these are the things that manufacturers went to. So Just like the water cycle, if you are familiar with that, PFAS pretty much has the same cycle and very similar. And so in essence, what's happening is that all we're doing is we're just moving those PFAS particles all around the environment. Nowhere in this diagram are we actually breaking that cycle. Nowhere are we removing it from the environment. Nowhere are we breaking that bond between the carbon and the fluorine. So in essence, all we're doing is we're just shifting it from one area to the other. And so it pretty much starts with the manufacturers on the left-hand side, and they create a product. They sell it to the stores. We go and buy that product from the store. We bring it to our house. We use it. So let's say it's a shirt or something that is coated in PFAS. We launder that shirt. It comes off. The PFAS comes off, goes into the wastewater from our laundry, goes to the wastewater treatment plant. If the manufacturer then has a wastewater that they produce, they treat it. Sometimes they don't treat it to remove the PFAS, so they basically just discharge it to the environment, or they discharge it to the wastewater treatment plant. From the wastewater treatment plant, our treatment plants are not designed to remove PFAS, so they pretty much just goes through the process. It's either absorbed in the sludge or the biosolids that are produced in our wastewater plant, and we either take that to the landfill or put it onto crops for the fertilizer, and then we have the discharge out of the wastewater treatment plant, then which goes to the rivers, lakes, and streams. From the landfill, there's the stuff that we use, that we buy from the store, that is stain resistant, water repellent. Over time, we got to get rid of that stuff. Where do we put it? We put it in the landfill. And so what happens in the landfill, whether it rains on top of the landfill, the water soaks through all the material in there, and as that material breaks down, you create what's called a leachate. So you have a liquid material that you have to get rid of. That leachate is typically brought to the wastewater treatment plant, and then is treated there, and any PFAS in there, again, goes right straight through, either discharged out the effluent to the treatment plant or is brought up into the biosolids, and we take it back to the landfill, or we put it back on the farm fields. Out in the farm fields, the crops may uptake it, or it may actually leach into the groundwater or the surface water, and it's just basically a round circle. Is that we're just going around and around. So what we're trying to do is figure out, where do we break that cycle? Where do we have to get rid of this PFAS? And I think it all pretty much starts with the manufacturers, and that's we're getting towards that right now. And I'll talk about that here in a minute. I thought these graphs or maps were really interesting. These are from the Environmental Working Group, and it just kind of gives you a progression over time of how states we're starting to look at PFAS. Back in 2017, there were very few states that were actually looking at PFAS in drinking water. As you can see, there's a lot of dots in Michigan. So they were one state that was looking. Over on the East Coast, there was New Jersey. They were looking for it on a state level. California did a little bit of dabbling into it, but they weren't real hot and heavy yet. So that was back in 2017. One note is, take a look at South Dakota. We've got one dot where we actually detected PFAS. That was in the city of Pierre. They actually had one well that was contaminated with PFAS. They ended up shutting off that well, and it pretty much got rid of the PFAS out of their drinking water. The levels weren't that high, but they actually was there. At the time, they had absolutely no idea where that PFAS was coming from. So that was 2017. Fast forward 5 years, a lot more states are starting to look into this stuff. So, it was becoming more and more of an issue. States understood that, they needed to start looking into this stuff. So now you're taking a look at California's got, additional. Colorado's really hot and heavy into taking a look at it and finding it. Illinois, Ohio, Alabama, the Carolinas, all along the eastern seaboard, they're all starting to look for it. And as you can tell, they're finding it in a lot of different places. And so what it tends to be is those areas that are heavily industrialized is where they're really finding it. So you think about Michigan, the automotive industry and everything else, and so they were finding it in those areas that were heavy in industry, and that's kind of what most of the locations are, except for Colorado. I think Colorado, most of it came from ski wax. Which was really interesting. And so they do have a few Department of Defense areas out there, and so some of it did come from that, but I think a lot of their contamination comes from ski wax. We are dealing with a couple of systems out in Colorado right now in our firm that some of that PFAS did come from runoff from the ski areas and got into the reservoirs and the groundwater. Come forward another couple of years, and now you can see things are really starting to fill in. And so there's some additional regulations that came out that were starting to analyze for PFAS in drinking water. Minnesota went out and started taking a look at it, and so they were finding it. It's really starting to become a big deal across the United States. In South Dakota, even there's a few more blue dots that we have in our state. Luckily, most of the detections are very low. They are below drinking water standards, and we'll go through that here, what those standards are here in just a little bit. We'll get into health effects, but first of all, it's, how does that stuff get in our body? So we have routes of human exposures. Number one, ingestion. We've got drinking water, we've got food, we've got contact, so we've got air, we've got soil, we've got sediment, and then the use of consumer products. And so that is absorbed into our body. And so there are all sorts of different ways that we can get PFAS in our body. And this is pretty much the same way with any contaminant, is that EPA will evaluate all of these and determine, what's the percent of exposure that we have from all of these different sources. So what EPA has come up with is a list of potential health effects. All of these are generally from human or animal studies, mainly animal studies that they've done. And so some of the health effects that they have determined could happen, reproductive effects, developmental effects, effects on the immune system, increased risk of cancer, and increased cholesterol and risk of obesity. I think the most typical health impact has actually been the increased cholesterol and increase in obesity. Those are the ones that they're finding the most frequently for PFAS, but they are seeing other things too. And unfortunately, some of these impacts can occur at very low concentrations. So EPA has now come out with their drinking water standards. These are the first standards across the water community. The column you want to look at is the one right in the middle, one where it says MCL, maximum contaminant level. That is the most that you can have in your drinking water. So every water system will be required to sample their water, analyze for PFAS, and there are 5 separate PFAS that EPA has set standards for. Compare that to the plus 14,000 that are out there. But at least, hey, it's a start. Okay, these literally are the legacy ones. These are the ones that are the probably the most important to be able to set standards for. The other thing I want you to look at is that it's 4.0 parts per trillion. This is the lowest concentrations for a standard that drinking water has ever seen. Typically, we look with parts per million, parts per billion. We're actually now into parts per trillion. That's 1,000 times less than let's say a standard for arsenic or something like that. And so these levels are extremely low. And so we've been talking to operators across the state as they have to sample for this stuff. You got to be extremely careful because you can contaminate your sample so easily when you're sampling for PFAS. You got to make sure that you don't have clothing that has PFAS on it or something like that. You are using the correct gloves and stuff like that. And so it's just trying to get operators to understand exactly what you have to do when you're sampling for this stuff, when you're looking at that low of a level. So what's 1 part per trillion? Just to kind of give you an idea. Okay, 1 inch in 16 million miles, 1 minute in 2 million years. It's just extremely small concentrations. And the one I like is for South Dakota, we have just over 2 trillion square feet in the state. So 1 part per trillion is 2 1 square foot tiles set across the entire state. And they actually have detection capabilities or instrumentation that they can detect down to 1 part per trillion, even less than that. And they're getting better. And so it's it's really interesting with this stuff and all of the advancements that they're making in analysis and detection and everything else. There are some states that have their own regulations. Before EPA came out with their own drinking water regulations, there were some states that created their own. The EPA standards are actually lower than any state MCL out there, so all those are pretty much done. However, there are still states out there that have other regulations that may be groundwater standards, surface water standards, prohibitions on the sale of products for PFAS, stuff like that. So this came through Safer States, and they monitor all of the regulations on a state basis as to what's dealing with PFAS. And so that's why we're seeing so many articles, research and everything else about PFAS, because it's definitely out there and everybody has it. The one thing I want to bring up is for the state of Minnesota, AMERIS law. This is going into effect January 1st. Basically, 23 days. It's going to prohibit the sale of products if that product contains intentionally added PFAS for 11 product categories. And so the listed categories are up there. And so manufacturers have been required for about the last 4 years to try to figure out, my product that I produce, does it have PFAS in it? And so they had to go back to their raw product that they had. So if it's some sort of widget that has 10,000 parts, they had to figure out which parts actually had PFAS in it, and if they did, they had to go back to that manufacturer and tell them, you can't have PFAS in this thing anymore. You got to provide us something that does not have PFAS in it. And so it's been interesting to monitor this. And we'll see what happens when January 1st comes. We'll see how many shops are basically going to close up, or somebody's going to walk into the store and they're going to say, I want a carpet. This is the kind of carpet I want. The guy's going to look at it. Sorry, can't sell it to you. It's got PFAS in it. So manufacturers are getting better at finding alternatives, but there are some out there that just they're not there yet. So we'll see what happens. The state of Maine was another state that was looking at this stuff and trying to ban it. They were actually ahead of Minnesota, but I think the manufacturers got to them, and so they kind of kept changing their law. And one of the things that they required is manufacturers to give them a list of products that contain PFAS. 3M gave them a list of 20,000 products that they produced that had PFAS in them. 3M has stated that they will remove PFAS from all of their products by the end of 2025. And so hopefully by that time, there won't be any additional PFAS within products that are sold by 3M, and other manufacturers are doing that. Textiles are working towards that. They're trying to develop new products that are stain resistant, water resistant. The thing that you got to realize is that they're not going to be as good as, what we had. They're going to be a little bit different. So if you have a tent or something like that that is water resistant, and you just love the heck out of that thing, when you got to buy a new one, it may not work as well, just because we're dealing with new products. So we'll see how that goes. We do have treatment options available at the water treatment plant. size. We've got reverse osmosis, ion exchange, granular activated carbon. And so those are all options that cities have or water utilities have at their disposal to try to figure out if they've got PFAS in their water, how am I going to remove it? And there are some utilities out there that have to go through this. Like I said, we're working through a few utilities out in Colorado that are going through this. Woodbury, Minnesota we actually designed the largest PFAS removal facility for them because 3M is over in the Twin Cities area. So this is where their PFAS came from. And so they are a 32 million gallon per day PFAS facility using granular activated carbon. And that's just starting construction right now. They do have a temporary facility up and running, but it'll take a few years to actually get the full plant up and running. Home water treatment units, we all have options to remove PFAS. Generally, they tend to be granular activated carbon filters or reverse osmosis are probably your best bets. Make sure you check that they are certified for PFAS reduction. NSF certification is the best way to do that. However, just as a side note is that the certification is not keeping up with the drinking water standards. So, and any of the certifications right now for NSF are not guaranteed for removal down to less than 4 parts per trillion. I think most of them can. Reverse osmosis won't have a problem because it basically removes everything. Granular activated carbon, you may end up just having to replace your filters maybe more frequently. The thing that when I worked with the water division in the water lab for the city is that maintenance is critical. It's always when you have your own home water treatment device, maintenance is critical. If you have to replace that filter, time's up, replace it. Don't let it sit in there any longer because you can actually make your water quality worse. And especially with PFAS, because PFAS will desorb from a granular activated carbon if you continue to add that compound to that GAC, and it'll actually desorb more. So you'll have more on your finished water, your water that you're drinking, than what's actually coming into the unit. And I probably went way over time, but I think Sammy's next. Emily will introduce her, and then we'll all come up for a Q&A afterwards. Okay, thank you.
Thank you so much, Tim. That was super informative, and I'm sure we all learned a lot and have a lot of questions now and probably some worries as well. So as Tim said, we'll do a Q&A at the end, but for right now, I am pleased to welcome Sammy Blood. Sammy joined the Department of Agricultural and Natural Resources as an environmental scientist in 2021. She graduated from Oregon State University with a Bachelor of Science in Natural Resources, emphasizing fish and wildlife conservation. She currently works in the Drinking Water Program, which implements the Safe Drinking Water Act in South Dakota. Sammy acts in a regulatory role overseeing South Dakota water systems to ensure compliance with the Safe Drinking Water Act standards she manages. She recently started managing the newly finalized PFAS drinking water standard for South Dakota. Sammy, welcome.
Okay, hi everyone. Looks like I should have started walking up here a little bit sooner. All right, so thank you for inviting me to present. I had to bring my notes because I also like to talk a little bit over, so I have to stay on message because I could talk about PFAS all day. So I am Sammy Blood with the Drinking Water Program. My area of expertise is the finished drinking water, which is your treated water, but my presentation will touch on a couple of other areas. I will be focusing on Sioux Falls region specifically, but if you have questions regarding other towns, if you are from Hartford or T or Brandon, feel free to reach out to me because I can talk all day about those towns as well. But you can reach out to me at a different time because I am only talking about Sioux Falls today. So I'm going to dive right in with a timeline of PFAS sampling in the Sioux Falls area. So at the end of 2011, I think it was around the December time, right at the end, Sioux Falls was invited to participate in an EPA study along with multiple other water systems around the nation. They are sampling multiple contaminants. Some of those contaminants included PFAS. They got the results back in 2012. Those results showed various detections of PFAS, including PFOA and PFOS. Those results were in the 3.10 to 4.45 parts per trillion range. I want to note that at this time in 2012, the EPA had a provisional health advisory level for PFOA that was 400 parts per trillion and 200 parts per trillion for PFOS. So 400 parts per trillion for PFOA and 200 parts per trillion for PFOS. So to explain what a provisional health advisory level is, that is a non-enforceable level. For example, if you get results at a health advisory level, the state, we can't tell you that you have to treat your water or do anything with those results because there's no drinking water standard that is on law. So at that time, they had sampled their raw water and finished water. So based on these results that they got, the staff, actually Tim Stefanich, he had researched PFAS compounds to try to find out, what is PFOA and what is PFAS? What does that even mean? There was actually not that much information out about these compounds at that time. There wasn't much by the EPA that was out there, but a lot of it kind of pointed to firefighting foam, which kind of directed their research and further sampling, which they elected to do. So in 2013, they took further samples on wells that were located at the airport and surrounding the airport. These wells, the results came back with further detections, and the wells with the highest detections, they decided to shut off immediately. That was based, again, around the health advisory levels at that time, that 200 and 400 level. And they were able to also do that because at that time, the city of Sioux Falls was working on turning on the supplemental water with Lewis and Clark, which you still have to this day. So it's feasible to be able to shut off those initial wells. Okay, so in 2013, 2015, there was additional sampling. The EPA is required every 5 years to issue a list that is no more than 30 contaminants that are not regulated that should be monitored for by public water systems. This is called the Unregulated Contaminant Monitoring Rule, and it is numbered by its cycle. And it provides the EPA and other interested parties in scientifically sound occurrence data. So in 2013, is referred to as the UCMR3. They sampled for multiple compounds, but specifically 6 PFAS contaminants were included, and Sioux Falls had no detections of PFAS at this time. This was specifically because of the decision to shut off those wells at the airport. So the reason why they had no detections again was because of shutting off those wells, and so you have had no detections of PFAS up to that point. So getting into Joe Foss Field. January of 2016, the Air National Guard submitted a PFAS site assessment to the state of South Dakota Spills Group. A spill case was opened and the Air National Guard was named the responsible party. In August of 2016, Sioux Falls reported detections in 19 municipal wells, which are going to be, I think you can see them okay. The red dots here are the impacted wells around the airfield, which, of course, multiple sampling between 2016 and the time that the initial samples at the airfield brought us to this map here. These green dots here are going to be wells that were determined to not be impacted, so there's not a lot. 2017, Sioux Falls was named as a potentially co-responsible party on the spill case. In 2020, a final site inspection report was received from Joe Foss Field. And today, currently, 2024, Joe Foss Field is working on remedial investigation, which determines the nature and the extent of PFAS around Joe Foss Field. So this is an image that I pulled from that final site inspection from 2020. That document is just under 1,000 pages long, so I tried to get an image here that summarized the more of the water side. Final site inspection includes groundwater, surface water, also soil samples. So there's a lot of data in there, but on here, let's pull my little clicker here. These red dots here and up here, got my laser here. Those are groundwater wells that are impacted based on a health advisory level that was finalized in 2016 by the EPA. They lowered that 400 and 200 to 70 parts per trillion. 70 parts per trillion was the working number for a while. And so, again, these red dots mean that they were above that 70 parts per trillion. Green dots are groundwater wells that had PFOA and PFAS, but they were below 70 parts per trillion. So you can see right here, there's just a few of them. I think maybe there's a couple up at the top. And then there's also a few samples here along the Big Sioux on both sides, I think. I can't laser on that side, but on the other side as well. So there are a few samples along the Big Sioux on both sides that are detections. Okay, did everyone have a chance to get a look at this before we move on? I know it's a lot to take in. Okay. Okay, so I want to, make sure all my words are there. I wanted to highlight some of the proactive decisions that Sioux Falls made through this time, especially at the beginning. So in that 2012-2013 timeframe, they voluntarily discontinued the use of the wells immediately when it was determined that there was high levels of PFAS. And then they made the decision to shut down all of the airport field wells. That wasn't at the directive of the state. They made that decision entirely on their own. They also put out messaging by doing a press release, and they participated in articles about PFAS when there was little guidance on what to say and the health effects. And I kind of noted on there, one of them that I found was they were on the front page of the Rapid City Journal. So you are able to also find that online. It's a story about the Ellsworth and the Joe Foss Field firefighting foam. So then they also made the decision to continue sampling after the health advisory was lowered to 70 parts per trillion, and that included the Sioux Falls connection and the Lewis and Clark connection, even though Lewis and Clark connection is a separate water system. They took the initiative to sample both of those water connections to make sure that your drinking water was safe. And it wasn't an occasional sample, they sampled monthly for quite a while. And then additionally, they sampled impacted private wells directly south of Joe Foss Field and worked with the owners of those private well owners to either connect them to city water or ensure their RO systems filtered correctly with additional sampling of both influent and effluent water. So that brings us closer to today. We are in the fifth cycle of the unregulated contaminant monitoring rule. This cycle has selected 29 PFAS, which is a little bit more than the 6 that the UCMR3 sampled for. Sampling is still going on for a lot of the water systems across our state. Sioux Falls has finished their sampling and they have had no detections still to this day. That brings us to the finalized PFAS standard. This was finalized in April of 2024. This does impact hundreds of water systems across our state. The levels that are enforceable now, of course, are very, very low. As Tim mentioned, PFOA and PFAS are down to 4 parts per trillion, which is a big drop from that, the latest health advisory level that was at the 70. But a lot of water systems already knew that this was coming and were prepared, including Sioux Falls. One step of this, there's a lot of steps of this rule, which is one thing that is part of my job, is to read through the PFAS water standard when the EPA puts it out and give direction to our water systems. One thing that has started now is initial sampling. They have until the end of 2026 to get that requirement done. Sioux Falls did it right away. They are done with that. They had no detections. Compliance sampling starts in 2027. It will be very similar to what water systems do for all of the other contaminants that they sample for. It is based on the initial sampling, if they will start on quarterly monitoring, or if they will start on reduced monitoring. The EPA did put this into their finalized rule because other states, they do have a very robust sampling, such as Michigan and Minnesota. They've been sampling for a long time, so they wanted to be able to use that previous data. This also does include the public notices for customers. For example, if a water system doesn't take a sample, or if you have samples that are above those allowable levels, that you would be notified. And there is also your annual drinking water report that gets sent out from your water system. If they have detections, it would also be in that drinking water report. So for the state of South Dakota, data collection for us is huge. You saw on that map, there weren't a lot of dots for us on that map. That's a lot because there hasn't been a lot of sampling in South Dakota up to this point. So for us, where is the PFAS and in what levels? There is, for me anyways, in my opinion, there's never too much data. And so, this drinking water standard is going to be the first big push for us to get a lot of data collection. And that is going to be our first step, is in the drinking water world. It's going to be our first big influx of data, and it'll be bringing in a lot because it's kind of our first big step into the PFAS world. So I would expect to see more dots coming up on the map in South Dakota. Other sampling projects that are going on, you'll hear an update from Jay on sampling the Big Sioux, and I've heard of other projects that are planned in the future, similar projects that are planned across the state, and there's other private sampling that people do across the state just on their private wells, and there's also military sampling that goes on as well. For other programs, like I mentioned, I'm with the drinking water program, but there's other water program, the surface water program, Water Rights. They also plan sampling. They are a little bit behind the drinking water world simply because drinking water, I say we kind of beat them to the punch, where first we got a finalized standard. So, it's a little bit easier for us to have an action plan, but they are actively working on plans of where they want to sample first, and you kind of have to prioritize and make those plans and move forward. But it is in the progress there. And then data compilation is going to be big for us. We want to figure out a way that we know people want to be able to see the PFAS data, and we want to make it accessible. And so as this data is coming in, we're trying to think of a way to best put it together and make it so it can be easily viewed by people on our website. We're working on putting together just a main PFAS page for people to be able to, a landing page for people to look at the data results. And then lastly, because Dana is a merged department. We consider it a strength for us. We do have a PFAS team, and so that way if there's ever a PFAS incident, because it doesn't only affect one program, you can send in whatever PFAS issue, and it goes to multiple programs all at once. We don't have to bounce an email back and forth. It just goes to our team group, and whatever the PFAS issue is, whether it's a PFAS spill or a PFAS question, you're actually reaching a multi-person team to handle it quickly. So I also want to highlight the Sioux Falls Water Purification Department while I have a chance. And so this team is actually a pretty hardworking team. They actually I think it was last year, the year before, they won a 20-year award for drinking water excellence. They also placed 3rd place in the national Best of the Best water taste test, along with multiple first places at the state level. The city has a pretty future-focused sustainability plan. And especially when it comes to water conservation, I've seen Ted Lewis give talk about their water conservation and sustainability plans. And then they really do a great job on their public education. That's what that picture on the bottom is. It's when they were doing their lead service line, inventory. That's all lead service line related pipes and different pipe types. And then that up there is actually Tim Stefanich, because I found him on the internet, so I had to put him on there. And then lastly, what would be a presentation if I didn't include a call to action, right? Because that's what a good presentation is. So, this is, your Sioux Falls region, your resources. Put some nice iconic pictures of the Big Sioux up there. So the first thing to think about is, what do you know, and what resources are you missing, so you can fill in the gaps. If you feel like you want to know more about PFAS in general, this is a great way to start, but there's a lot of information also online that you can get, so you can really dig in more. Also, who do you need to talk to? There are a few people who just really enjoy PFAS, and you're looking at one of them. So I will talk to you all day if you want, but if you want to talk about just water quality in general, your city staff is a great place to talk to too. Or again, if you want to talk to me, I'm all game. You can call me and I'll talk all day because I've got nothing better to do, I guess. And then how can you get involved? Coming to conferences like this, networking. If you want to go further, there are always projects going on in the Big Sioux, and there's always, depending on what type of work that you'd like to do, there's always projects, and we can find a place to plug you in. I think that's it. And that's my contact information, so screen grab that if anyone wants to call me, because I will talk to you.
Wonderful. Thank you so much, Sammy. That was very informative, and I'm sure folks will have questions just like they will for Tim as well. I'll leave that up there in case anyone wants to grab a photo of Sammy's contact information. But now it is my pleasure to introduce Jay Gilbertson. Jay is the manager of the East Dakota Water Development District, a position he has held since 1994. He oversees a broad range of district-sponsored activities focused on water resources, including surface water and groundwater assessment, monitoring and protection, environmental education activities, and water policy development. Today, Jay is going to be discussing the preliminary results of PFAS testing that was done in the Big Sioux River this year. Jay, welcome.
2 slides. Half an hour tops. Anyway, again, Jay Gilbertson with East Dakota. Heard a lot about PFAS, that's great. Most of the information that's been collected so far about PFAS has been done because it's had to have been done. The initial discoveries here in Sioux Falls were because UCMR 1, 2, something like that. 3 was in there. Now there's a lot of the UCMR 5. All of that is directed toward drinking water. What's coming out of the treatment plant going to you, the public. Earlier this summer, I was quizzed by a number of operators. Well, what do we know about where it is? Now, if it's in my plant, or if it's in the water I'm sending out, it's either coming from the plant or it's coming from the source. well, where's it coming from? What do we know? And in particular, what do we know about the Big Sioux River? And the answer was, we know nothing. There was no information available, at least publicly available, about PFAS in the Big Sioux River itself. And so we thought that sounded like something that we could fix by going out and sampling. It was clear that it wasn't going to be done, or wasn't being done by the state, at least not at this point. And so we set up a quick project with the folks out at the School of Mines. See the Big Sioux River map over there on the left. We started sampling up near the headwaters of Summit, and then at 11 different locations, ending at the State Highway 42 bridge heading over toward the casino just south of Brandon. We didn't go all the way down to the south because my district only goes to the Minnehaha County line. So we're not going to go sample down in Lincoln and Union County because, well, hey, that's not our territory. Let them do that. The picture of the folks doing the work for us in the foreground is Dr. Lisa Kunza, one of the few faculty here in South Dakota who currently working on PFAS research activities. In the middle is Jenny Kozak, a graduate student who's doing the work on this project, and then finally Kevin Christensen, who is basically Sammy's counterpart. He's the king of PFAS in South Dakota, where she is the queen. Kevin works for the Rural Water Association and is doing most of the sampling of PFAS for a lot of the public water supplies across the state. We did one sample. Well, we're going to do a total of 5 sampling runs, 1 in September of this year, 4 more next year. So first off, I have to point out these are results of a single sampling run. And while 1 sample is infinitely better than 0, it's not a whole lot. Don't want to hang your hat on that. A little bar chart over on the left. Our sampling methodology looked at 40 different PFAS compounds total. What the bars represent are the total amount of compounds in parts per trillion for that whole 40 sample suite. We found a total of 14 different compounds in there. If you start over the left-hand side, those are the headwaters. Very, very low numbers, but still there. There was something there even as far north of Summit. The first big bump is the sampling site below Watertown. And as we've heard earlier, a lot of the stuff, as Tim noted, ends up in the wastewater treatment stream, which then turns around and sends it right back out into the environment. Well, up in that part of the world, that environment's the Big Sioux River. So not surprising there's a big jump in concentration below Watertown. From there, down to the next big bar, we're working our way down from, the Watertown area through Brookings, Egan, and just ending up down on the north side of Sioux Falls. And the concentrations are pretty low, even though we had a pretty big spike, relatively speaking, big spike up at Watertown. This is a function of dilution, okay? On the right-hand side, we've got the guesstimated flow volumes in the river at the time the sampling was taken. Up at Watertown, we had about 20 cubic feet per second. So a little bit of stuff going into a small amount of water will give you a relatively high concentration. If you don't add any more stuff to it, but you have a 10-fold increase in the volume of water, that concentration is going to crash, right? You're going to get lower numbers. So one of the things I figured out almost immediately after the first run is we also need to have flow data for all of these sampling sites to know what's going on. But anyway, getting into Sioux Falls, nothing, and then we get one huge giant spike. Okay, that is Falls Park. Sample collected at the bridge there just at Falls Park. Lots of stuff was found there, relatively speaking. A couple of the compounds were detected at levels that would be considered in excess of the applicable standard if this were drinking water. This is surface water. There are no standards for surface water. Okay, I repeat, there are no standards for surface water. It clearly shouldn't be here, but there are no standards that are applicable. The reason for the big spike, a couple of things. One, it's big because there's hardly any flow in the river at that point. Most of the water in the Big Sioux River that starts north of town gets diverted through the diversion ditch. You know, about 10% of the flow is coming down over the falls and going through the city itself. So even a modest contribution is going to get a relatively high bump. What's happening? And then once we get below there, the last two little bars, everything drops. Well, again, that's because the diversion flow is returning. The concentration is dropping. We've got additions from the wastewater plant, Smithfield, and other things. So we've got there's some stuff going on. The bottom line is there's stuff in the water. Where's it coming from? Well, I think we don't know is the answer to put onto that. Our sampling was not designed to target sources. It was set up to get a baseline of what's in the river itself. Now, based on what we know about the occurrence of PFAS sources in the basin, it's not hard to speculate where it's probably coming from, and we're going to need to do a little more targeted sampling. There are a lot of things happening between any one of those dots on the map, that any one of which could be a source. There are certainly things that are more likely to be sources than others, but we have to do some additional sampling. But at the end of the day, our first run at this, there's not unlike almost anywhere else in the country, there's PFAS in our water. Big surprise. And we're going to have to start dealing with it. One of the things we're hoping to do is provide information, though, for folks down the line. If you live below Sioux Falls or you live below one of these sources and you use the river as a resource, be aware it is there. Don't wait until it shows up in your UCMR 5 sample of water you've already treated. If you know it's coming, as the city did, maybe you can shut those intakes down, you can shut the wells down and not have to deal with it. If you don't go looking for it, you don't know it's there, you don't know to prepare. And I'll quit and we'll hear about Travis's blood, which is going to be really interesting. Thank you. Yeah, ruined the surprise.
Hi, it's me again. Real quick, I don't want to spend a lot of time on this because we want to get to Q&A. But I was curious, what's in my blood? What kind of PFAS levels are found, in everyday life? So this is what I found. I got a take-home test off the internet, and I did a blood sample, and they found some PFAS in it. I don't know if you'll be able to see this, but on the far right side, the serum equivalent, that's equivalent to what the standards we've been talking to or about today. And you can see I'm just a dude in the Midwest, middle class guy. We don't have a huge industrial, facilities in this area, and I still have 2.2 parts per trillion in PFAS and 2.85 in PFAS just in my system. And this was about September, October. So again, what does this mean? I don't know. But I find it interesting that, in our everyday lives, we are, as we've been talking about all day, are exposed to PFAS in various levels, and it is bioaccumulating in your system. So that's really all I wanted to say about this, but it's interesting that it's there. I don't know what this means, but it's a good starting spot to be aware of your overall health trends. So anyways, okay, well, with that, I want to thank you all for coming today, spending your morning with us, and let's give our presenters another round of applause. And yeah, thank you all.